Good afternoon and welcome to NASA's Johnson Space Center and our spacewalk briefing for today. We've got an exciting lineup of 10 spacewalks coming up in the coming weeks, and we've got a great group here to tell you all about them. We're going to open up today's briefing with opening remarks from these guys, starting with Kirk Shireman, the ISS International Space Station Program Manager, Megan MacArthur, who is the Deputy Chief Astronaut, Flight Director TJ Creamer, and Spacewalk Officer Keith Johnson. So we're going to hear a little bit from them, and then we're going to open up the room here for questions. So, Kirk, we'll let you start.
All right, thanks. What I'd really like to do is start off and give you just a rundown of what life's been like the last week, and I think that kind of sets the stage for these EVAs. So last week we launched 3 crew members to the International Space Station, actually, last weekend, Sunday, we launched HTV rocket with HTV spacecraft coming to the International Space Station. Then we launched an ISS crew. The crew got there. Then we had the HTV berth. Then we had a crew land. And now we're going to do spacewalks. And so all that really is in a period of now 10 days or so. That's kind of what our life is going to be like for the next few months. So we set up a series of spacewalks, which you'll hear about, but the real critical thing is this HTV that arrived last weekend is going to brought batteries. These batteries are not like batteries for your flashlight. These are really big batteries to store energy from the sun and our giant solar arrays, critical for maintaining and operating the International Space Station, for conducting all the research that we do. So we're going to replace those batteries, and we have to get that work done. And so we're gonna do that, and then after that we have these alpha magnetospectrometer spacewalks, which are really exciting. We're going to repair this experiment that was actually manufactured here on the planet by a group of countries from all over the world. It was never designed to be touched again. By the way, whether it's people sitting in a laboratory in a shirt sleeve environment, much less people 220 miles above the Earth going 17,500 miles an hour working from inside of a balloon like we're going to do. So it's really exciting, highly technically challenging, and all that's going to happen here over the next 2 to 3 months. By the way, while we're doing that, we're still going to have a Northrop Grumman Cygnus vehicle come up to the ISS. We're going to have a SpaceX Dragon come up to the Earth, and we're going to still conduct a tremendous amount of utilization, experimentation, commercial activities. So you can see that it's a really, really busy time. It has been for the last week, and that pace is really going to continue, both for the folks on orbit and also on the ground. Really, really important time for ISS. It'll be exciting and fun. So we're looking forward to it, and I know we'll be successful. You said 10 EVAs. By the way, there's an 11th EVA. It's a Russian spacewalk that's planned in this time frame. But as everything goes, you know, there's always, I was going to say surprise, you always learn things along the way. And so I always say it's approximately. My friends over here say it might be more. I always say it might be less. We're still negotiating, but we understand the program. I want folks to understand out there that as we go along, we're going to achieve these goals. We are going to complete the battery task. We're going to repair the AMS alpha magnetospectrometer. It might not happen exactly the way we envision today, but we are very good at adapting, and I know that we'll be successful. So with that, let me pass it on over to Megan, and she'll tell you a little more.
Thanks, Kirk. Well, as Brandy said, this is a really exciting time. Every astronaut dreams of getting to do spacewalks, and we have 10 now coming up really fast, so it's kind of a spacewalk bonanza. So the sequence of 5 in the beginning to upgrade the solar array batteries, those fall under what I would call requiring skills-based training. And so all of our astronauts that are qualified EV crew members, and we have 4 qualified crew members on board, they've all had the generic training and demonstrated the generic skills required to do EVAs that fall in this category. What they haven't seen is the specific end-to-end timeline that's been created to do each of these tasks that the team has put together. So what we do is we provide them study time on orbit to study the plan and to think through all of the different tasks that we'll do. And then we provide someone on the ground to talk them through each step of the way. So for this first spacewalk in this first series, Christina Cook, who participated in the previous series of battery EVAs, she has actually been to this work site. So she will be the lead spacewalker for this first EVA, and joining her as the EV2 will be Drew Morgan. Luca Parmentano will serve as the suit IV for this EVA, and Jessica Meir, in her first on-orbit EVA activity, will be helping him to suit up the crew members. Then she will serve as the primary arm operator for the activity, and Luca will assist her with that. Stephanie Wilson, an astronaut who will be here on the ground in Mission Control, will be the ground IV, the choreographer basically, who will be talking them through all of those tasks during the EVA. So that's the first one. So there'll be 4 more in the sequence. Again, all 4 of the USOS crew members that we have on board are qualified to do these EVAs, and it's our goal to share that experience and complete these tasks in the most efficient manner while also growing the experience within our astronaut corps. So the second in the series of 5 will be also Christina and Drew during that second EVA. The third EVA will be Drew, then joined by Jessica in that third one. The fourth EVA will be Christina Cook, joined by Jessica Meir. And then the fifth EVA will be Jessica, joined by Luca Parmentano. So that will close out the sequence of 5 EVAs. Again, we're planning ahead. This is a sequence of 5 spacewalks. It's going to take us almost a month to complete them. Lots of different things can happen with the not only with the EMU hardware, with the spacesuit hardware, but with other things on the station affecting station priorities. So that is our plan going in. Lots of things can perturb that plan, but we'll be prepared to respond to that if we see those changes. So the second sequence of 5 spacewalks that Mr. Sharman referred to for the alpha magnetic spectrometer enhancement or repair, those I would put in a different category that's more similar to the kinds of spacewalks that we did in the shuttle era. They're more what we would call requiring task-based training. So not generic skills, but very specific to this task. As Mr. Sharman said, the instrument wasn't designed to be repaired in space, so unique tools had to be developed, unique procedures, unique comm protocols had to be developed, and so we had to basically make our best guess of when the sequence of spacewalks would happen, and then look to see which crews had time available in their ground training to give them that specialized training to work with these tools and on those tasks. So that series of 5 spacewalks will be conducted by Luca Parmentano and Drew Morgan. And then inside we'll have Christina and Jessica will be doing the suit up and the arm operation. So that's the lineup for those 10 EVAs that are coming up. Over to you, sir.
Well, thank you, ma'am. Appreciate it. So as Megan alluded, we've got a campaign of EVAs in front of us specifically for the batteries and also later for AMS. The key thing about the P6 battery R&R series of EVAs is that we're going to be able to take out some old batteries and replace them with new batteries with greater capacity. And the end state is going to be better for station's longevity and be able to service the mission that we're up there to conduct the utilization experiments more fully. In order to prepare for those EVAs, there's a long line of coordination and choreography set up to help both the crew, starting back many months ago when crews are starting to run through procedures in the pool, practicing the choreographies, and we're honing our procedures, we're honing our coordination with the ground IV, Stephanie Wilson, up to what's happening now. We've recently been able to use the robotic arms on the outside to be able to prepare the new batteries. We've released one of the 2 bolts. We've broken the torque and reset the torque on the second of the 2 bolts, holding down the new batteries on the pallet. And we've also begun the power draining of the old batteries. We don't want batteries to be live to provide an electrical energy source that could cause problems during the EVA. So we're draining the old batteries as we speak right now. Now, if you think about it, those batteries were there to power something. And those loads downstream inside Space Station, we've allowed another power channel to pick up the electrical supply for those loads. So not only the batteries, not only the robotics, but we're also positioning the big solar arrays in the right place. We're moving the arm out to the far port side. And then on the inside of Space Station, we're giving the crew the opportunity to study through the procedures, not only the procedure that they're going to go out and do on Sunday, but also a little bit of a bigger picture to include the follow-on EVAs so they understand where their activities are fitting in this campaign. In addition, as the crews step into Sunday and they start doing their actual suiting up and preparations, we're beginning to condition the environment to help them denitrogenate their blood system so they're ready to go out in a lower pressure environment. And then Sunday morning, 6:55 Houston time, we should be opening the hatch and exiting. And that sets up the long story of what we've been doing and what we're going to be doing technically. And I can turn it over to Keith to talk more about the choreography.
All right, well, thank you, TJ. To point this out, we've got several sets of solar arrays that are out there on station. And each of the sets of solar arrays have their own integrated equipment assembly that are the batteries and all the charge and discharge capability of those batteries. And we, in the past, have had opportunities to change these batteries out. On several missions during the shuttle era, we changed out these specific batteries, but we put the old batteries back, the same kind of old batteries back in again. They're nickel hydrogen batteries. This time, we're replacing those batteries with lithium-ion batteries, and they hold quite a bit more of a charge. They're much better batteries. So in place of 2 of the nickel hydrogen batteries, we now put in 1 lithium-ion battery to take the place. But you have to complete the circuit. So the 2 batteries that we've taken out, we put in a new lithium-ion battery, and we replace the other one with an adapter plate, and we hook the wiring up between the 2. These batteries are big boxes, and we are out at the extremity, and I think we've got a picture here that I can show. You can see the station layout. The inboard solar arrays were accessible by the arm, so that allowed the robotic arm to do a lot of the battery change out, the pieces back and forth, but they couldn't hook up the electrical connector, so we had to send out EV crew members to go do that. With the outboard batteries, the ones that we're going to do here on the port side that you can see at the right hand of the screen, the robotic arm can't reach. So it gets as far as it can go with the exposed pallet, which holds the batteries and the adapter plates. It's a long way out there. It's a long translation path. But then the crew members have to go back and forth between this pallet and the integrated equipment assembly to do this change out. So I think I have another slide here that kind of shows more of the work site. Well, let's see. So here's the one that shows, thanks, what the integrated equipment assembly looks like. It is 2 pair of batteries that are hooked up to what's called a battery charge-discharge unit, and that creates the circuit. And we're taking 2 nickel hydrogen batteries out, and you can see in one or the other of the case, we're either hooking up an adapter plate and the lithium-ion battery, or we're hooking up the lithium-ion battery and adapter plate and putting an old battery on top. And that's because we can't bring all of the old batteries home. They're going to go back on the exposed pallet, and they're going to come back on HTV and re-enter and burn up on their way back in again. So the next slide shows the arm positioning and the work site where the crew members are going to work. The arm's pretty stretched out there, and it holds the pallet, and the crew members set up foot restraints out on the P6 truss and also closer in where the exposed pallet is. And they'll shuttle the batteries back and forth. The old ones will come out of the IEA and go over to the exposed pallet, and then they'll take new batteries off and move those back out again. So really, the choreography that the crew members have back and forth is very important because they're going to be moving a box that's about 428 pounds and taking it off of the pallet and moving it out to the integrated equipment assembly, and then they'll take off an old battery which weighs about 365 pounds and bring that back again. So it takes 2 crew members, and they handle it between the 2 of them, and they go very slowly, and it's what we call shepherding. They'll have a hand on it, and one crew member will move a little bit farther along and get in position, and then the following crew member will push the battery forward and hand it over to them. And so it's kind of a shuffle back and forth. We call it inchworming as well as shepherding. So it's kind of interesting going back and forth, and it takes about an EVA to do a pair of batteries. And so that's why you'll see us doing this over a stream of 5 EVAs, because we get some done, and we hope to leave it in a good state at the end of each of these EVAs, and then we come out the next EVA and pick up where we left off.
So to jump on real quick, because we have the new graphic up, of course, we had the new graphic up. There you go. In both cases, in the green box as well as the blue box, you have some semblance of scale. You see an EVA crew member there, and you also see the batteries that they're working with. What I wanted to point out to y'all is that if you imagine your kitchen refrigerator, and you chop your refrigerator in half, that's about the size of these batteries. So it's a volumetric, it's a bit of a volumetric challenge to maneuver these together, since we have to go intrimming back and forth.
And while this graphic is up, the other thing to note is up near the blue box, you'll see the EV crew member. The arm positions that battery in place, and then it maneuvers to the next battery. So that crew member, that's going to be Christina, will come over, she'll ingress that foot restraint, and then the arm maneuvers to where she needs it to go to take a battery off and put it back on again. So the robotic operator inside is going to be flying to a position where that battery can be accessible. So there's communication between the EV crew members and the IV crew members, the crew member flying the arm. And I do have a model here of, this is kind of nifty, and this is why you do 3D printing. So one of the things to point out, and my hand's going to be shaking because I'm nervous, but so in our model, I don't know where you can see this best, we have 2 grapple positions, and one of them is the one that the arm holds onto, and the other one is the one where they park it so the arm can do the robotics operations that we've talked about earlier. They'll break the torque on the bolts and they'll get ready to move it off. Then the arm grabs it and extends it as far as it can to provide access for the crew members to work at the various locations. Our model will show you that we've got 3 open spots. That's where we're going to put the old batteries. And then when we take the new batteries off, and now's a good time to practice with this, and we hand a battery off to a crew member, and we can do the shepherding here as a demonstration, back and forth. Then we'll also take out what's called an adapter plate, and it's actually just to complete the circuit between the new battery and the next spot over on the IEA. Little demonstration there.
Nice.
For those of you who are familiar with the usual NASA spacewalk briefings, you're used to seeing the step-by-step animation with every move on the spacewalk kind of detailed. And we are still making those. We did not think we could fit them all into one briefing. So we're going to be posting those individually online instead. So you can look for those on nasa.gov. But also, and that was a lot of information there. Hopefully you caught a good deal of it. One thing that we did mention was that Jessica Meir and Christina Cook are going to be paired up for the 4th spacewalk in this series. They actually got asked by a reporter earlier this week whether or not there was a possibility that they could be doing one together. They hadn't gotten the final assignments for the spacewalks yet, but they talked a little bit about it, and we thought it might still be helpful to play back for you here now.
Okay, Christina, you just said you've got 2 medium spacesuits ready to go. Is there a chance that we are going to see Jessica Meir, Christina Cook, all-woman spacewalk going on?
Yeah, so right now we have 5 EVAs coming up, 5 spacewalks coming up to replace the batteries. So basically to upgrade to the new lithium-ion batteries that will better serve the power supply aboard the space station. Since we have a series of 5 spacewalks coming up, and we're doing that in a short proximity of time, as Christina mentioned, everybody up here is fully qualified to do a spacewalk. So I think that we can see any possible combination of personnel going out the door. We'll all be doing spacewalks, and there'll probably be several different combinations. We still don't know the final assignments for all of those, but yeah, there's a chance that we could be doing it together. Just any of the combinations are a possibility.
Christina, this is a question for you. There's been some press about how you're slated to set this record for the longest single space flight by a woman. I'm genuinely curious, does it ever bother you that your accomplishments are often talked about in terms of your gender, or do you think it's really important to mark these milestones?
That is something I've done a lot of thinking and reflecting on. And in the end, I do think it's important. And I think it's important because of the historical nature of what we're doing, and that in the past, women haven't always been at the table. And it's wonderful to be contributing to the human spaceflight program at a time when all contributions are being accepted, when everyone has a role, and that can lead in turn to an increased chance for success. There are a lot of people that derive motivation from inspiring stories from people that look like them, and I think it's an important aspect of the story to tell.
What about you, Jessica? How do you feel about it?
I think Christina gave the perfect answer. You know, it is really what we're doing now shows all of the work that went in for the decades prior, all of the women that worked to get us where we are today. And I think the nice thing is for us, we don't even really think about it on a daily basis. It's just normal. We're part of the team. We're doing this work as an efficient team working together with everybody else. So it's really nice to see how far that we've come.
All right. With that, we are next going to take some questions. We're going to start here in the room, but if you are on the phone or following us online, you can also get your questions in. If you're on the phone, use *1 to let us know that you have a question, and if your question gets answered, you can press *2 to withdraw it. And if you are following along on social media, you can use the hashtag #AskNASA to let us know you have a question. We'll be watching for those. But we'll start here in the room with Mark Carreau.
Thank you, Mark Carreau for Aviation Week and Space Technology. I want to ask about the AMS, if I might. I believe it was a couple years ago, next door at Space Center Houston, you did a pretty thorough, maybe not all of you, but there's a pretty thorough explanation of where the AMS was, and they were beginning to look at the problem. So my question is, can you describe the performance issue that you want to deal with, and how long, since this is a complex shuttle-like spacewalk that on equipment that wasn't designed to be dealt with space, how long have you been planning, preparing the procedures?
Let me take that one. So, Mark, as much as I would like to describe to you the particle physics involved, that's not going to happen. So I'd be happy to give you Dr. Ting's email address. We started working on this. So the issue with AMS is it looks at cosmic rays that enter the instrument. It kind of looks like a big bowl, if you will, but actually it captures or reads cosmic rays that enter from multiple directions. So it doesn't require them just to come down the bore of this bowl. They can come through the sides in any direction. They measure the charge, so they run it through a giant magnet. One of the cool things about AMS is it's a permanent magnet, a really, really big, very well characterized permanent magnet. So if you picture an electron coming through, it bends one way. If it's something with a positive charge, it bends the opposite way. They can measure the speed because there's multiple planes at which they measure it. And ultimately they measure the energy, which again you can kind of, if you take the speed and you measure the energy, you can actually figure out the mass. So what kind, there's all these types of cosmic rays, and again I won't even pretend that I know all those, but that's what they do. Well, in order to measure the energy, now picture these are you know, subatomic particles really. They have to have very precise instruments, and they need them very cold. And they use a coolant, in this case they use liquid carbon dioxide as their coolant. And when they designed the instrument, they designed it with this carbon dioxide, and they have these pumps that go from that cool the instrument that measures the energy out to a radiator. And what's happened is over the years it's been on orbit, every one of these pumps has failed, and it's down to the very last pump. And even that pump is showing the characteristic signature of failure. And so what they have been doing for the last close to a year has only been turning it on during certain periods of time. Really it has to do with the angle that the sun is relative to this instrument, but they've been babying it this last one. And so today, as we speak, there's still one pump, and they're using it some percentage of the time. What we're going to do is really simple. We're going to go in, we're going to snip some of these cooling lines, and we're going to install another series of pumps and replenish the carbon dioxide, and that's it. That's all we're going to do. Sounds very, very simple. But you have to understand, this device was meant to be never touched again. So it's got all these tiny fasteners. If we were sitting here in this room doing it, we would lose some fasteners. So here we are in space where we don't like to create debris. These tubes that we're going to cut, instead of all being separate and really easy to work with, they're all bunched together. There's 8 of them bunched together, and they're they're actually smaller than my pinky, and we're going to go in there and snip them. And by the way, they're all identical. So it's not a matter of the red one or the green one or the blue one. No, no, no. They're all silver. They all look completely exactly alike, so you can't cut it and then figure out which one's which. So even the choreography of this, and then finally, just for fun, we put it in this tiny cubby hole that you can't, it's hard to see and get into, and then you have to reach way out to do some of this activity. We created a suite of tools, which I'm sure we'll come brief you on, to make all this possible. Don't lose the fasteners. Make sure you don't lose track of which line that you cut. So the cool thing is when we finish all, by the way, the leak. When you do all this, you cut this tube with a pair of, not a scissors, but a tube cutter, and then we're gonna hook these other tubes onto it, and it can't leak. It has to. The leak rate requirement is times 10 to the negative 4, so all that has to happen to get this instrument back up to full capability. We've been working on it about 3 years. So the team started off figuring out how in the world, but it's got these shields and all this stuff, access, all these things I talked about. They went through all those problems and really have very good, solid solutions for all those problems that we know of. And Luca and Drew have been trained extensively. Maybe these guys know, I can't tell you how many NBL runs they've had, but we also have another facility called Argos, which they basically do it in a pressurized environment, in a shirt sleeve environment, but they take the mass off of them. And all this work has been done. Tremendous amount of engineering work to do the leak rate. It's a phenomenal effort to get where we are. I believe we'll be successful, and when we actually do it, it'll probably be really boring to watch, but it will be the most complicated series of EVAs I think we've ever done. So when we get to those, it'll be really exciting to talk some more. We'll have the people we'll even have a physicist here to talk to you about, but really cool stuff.
Yes, and we do plan to have another briefing specifically on the alpha magnetic spectrometer spacewalks. So we'll be putting out the date for that once we get a little closer to those spacewalks. Let's have Gina next. Sure.
Okay, let me start with TJ. Oh, sorry. Gina Sinceri, ABC News. For TJ, so the issue with moving the batteries it's clearly not the weight, but it's the mass. Tell me what's going to make that complicated for the astronauts.
So let's talk about mass first off, and also we'll talk about visibility. We don't really care about weight when you're in space and weightlessness, and I put that in quotes, because we can move a mass around in accordance with Newton's 3 laws pretty easily. The trick, of course, is once you get the mass going, you got to stop it at some point. So this got to overcome the inertia. So if you're going to try to get this into a minutely corralled space, you got to be careful, and you got to be using your fine touch, and you got to be moving slowly at those points. So focus more on the fact that this is just unwieldy, inconveniently large. But moving large objects, moving massive objects is very doable in space. You just got to be careful and go slowly. Keith emphasized the slow part, and that's one of the key things. The other one is the visibility, because if I'm going to hand you this half a refrigerator, it's taking up my visual field. So there's a lot of vocal communication to assure that we're going to have positive handoff and control of these boxes, the batteries.
If you don't mind, I'd like to add in on that too. When we take the battery out and we start moving with it, one side of it has 2 fixtures that we put little handholds on. So when you see the video, you'll see these blue things on this box that are blinking. They're what we call scoops, and they attach on 2 different places on this big box that weighs multiple 100 pounds. On the other side of it are fins. So these fins interface on the IEA to provide cooling for this box. So when we install this battery, we have to protect how we're putting it in, because if we dent this, if we damage it at all, it won't go in. So the 2 crew members put these little handholds on here, and then they hand it between the 2 of them. So they're moving a mass that they can't handle by themselves. It takes 2 people. There are only 2 places they can hold on to it. So they have to make sure that they hand it very carefully between the 2 of them. and they have to be very careful to protect the back end of this particular box. So all of that choreography and all of that motion is why we have to be so very careful moving these batteries.
Second one for Kurt. Any update for us on commercial crew schedule and launching? What's your crystal ball say?
You know, there's so much trouble I could get in there. So our tradition is, and I believe it's a good tradition, is we let the companies announce their dates. And because I hear so many dates about so many things, I'd be happy to find the latest dates for you. But I can tell you both companies are working very hard. I know that the next month, both SpaceX and Boeing are planning abort tests, and which is the next step. And then after that, we'll have a Boeing uncrewed flight test, or they call it OFT, orbit flight test. And we have Demo 2, which is flying 2 crew members on the SpaceX Crew Dragon. Those companies are progressing towards not only completing those vehicles and testing it, but also completing all the analysis and tests to make sure it's safe for crew members to fly. They're working as hard as they can, as quickly as they can. NASA's working closely with them. And so I can tell you we track it every day. We talk to them, we talk to the Commercial Crew Program, we talk to Boeing and SpaceX, and it's really progressing. The thing I'm excited about is this testing. Every test is really good. Even if it doesn't work exactly like we expect, it's still good information. And so all these things are very, very positive. They're working very hard, and I believe we'll see them soon. And maybe, Brandy, you know, but we'll find the official dates for you. And again, you know that those dates might change, and as soon as they do, we'll let you know.
Yeah, I think those dates are still under review right now, but we will put an update out as soon as we have one. So I think we've got another couple questions here in the room. We will again be taking some on phone, so if you have a question on the phone line, press *1. If it gets answered, press *2. Let's go to Robert now.
Hi, Robert Perlman with Collect Space. Just to dovetail off that question, not specifically about dates, but how it affects the schedule for these EVAs. What priority do these EVAs have over the other activities on station in terms of not necessarily commercial crew, but cargo arrivals and even science on board? If there's a problem during one of these battery swaps, can you take a break between that pattern of 5, or do they have high priority? And then in AMS, do you have that option to stop once you get started?
Wow, that's a lot. You should come to some of our meetings. So if you look at it, it's like a lot of things in life. If you look at it from 50,000 feet, it looks pretty cut and dried. So the 50,000 foot level is, we have the top priorities are battery EVAs, I'll call it perishable science. So we've flown some experiments up there. You can imagine that the samples will perish if you don't conduct that research in a certain period of time. By the way, not to imply crew members are perishable, but there are some experiments that are on the crew members. And like, for instance, you need to take some measurements from a crew member after they've been in space for 10 days. The fact that they need to do it after 10 days is a perishable thing. You can't do it after 50 days, you need to do it at 10 days. So perishable science, battery EVAs, AMS EVAs, and then additional utilization is below that. And obviously there's maintenance of the space station and so on. So that's the biggie. Now the hard thing, then you went on to some scenarios, which means it's a little open field running. That's when you get a little closer. Bottom line is there's some big constraints in front of us. So we took the pallet out here, or I guess, TJ, you may remember this weekend, I think.
Yes, sir.
HTV arrived. One of the first things we did is has this external pallet, the nice 3D printed one, with all these brand new fresh batteries. We took it out, and we had another pallet just like that full of old batteries that we had replaced previously. So we stuck the old one back in that HTV. So now we're hanging on to these new batteries. Well, the next HTV coming up with another set of brand new batteries is coming up in May of next year. And the interesting thing is that's the last flight of an H-2B booster. And JAXA is going to modify the pad for another type of booster, and it can no longer compatible. So we really have to complete all this. We have another pallet because we can only hang on to one of batteries. So that's a constraint. Obviously, exactly which crew members are going to be where in next year is a constraint that we look at too. So, and as we mentioned for AMS, it's not just, it's so task specific, you have to have crew members who've had a lot of training on that specific set of EVAs. So all those things fit into that relative to the batteries, if you saw that picture earlier that Keith showed, each channel has 6 old batteries, and we're going to put 3 of the new ones. We'd like to do that whole set. We'd like all or nothing. The truth is we can actually do replace 2 old ones with 1 new one and have the other sets be old. We could do 2 new ones and 1 set of old ones. We can do all those things. They're just versions of not optimum. So from a power channelization perspective, we'd like to do at least 3 before we stopped. And I know we're talking about 5. So we've looked at all those contingencies, and TJ or Keith could probably tell you a lot of that, what we would do. But frankly, it depends on what happens, when it happens, and all that'll fit together. If something happens like that, we'll come back and tell you. It's probably the easiest answer. Do you guys want to add anything?
I think you said it specifically, as specifically as you possibly can. So Robert, to dovetail just a little bit more, we have talked about natural stopping points. We have talked about if-thens. If we have issues, what do we do with a battery not being able to get seated correctly? What do we do at that point? So we've got a couple of contingency cases already mapped out. The goal, of course, is to get to a minimum of 2 of the battery charge-discharge unit strings to be completed on each of the power channels. We really want to get both the channel 2B and channel 4B 100% changed out.
Okay, we have a lot on the phone, so we'll take one more here and then we'll go to that.
Okay, and not necessarily about the possibility of an all-woman EVA, but more about how you come up with, can you talk a little bit about how you come up with the pairings for EVAs? The schedule has, for example, Drew Morgan doing the first 3 EVAs, and presumably that's part of getting his EVA legs for the later AMS EVAs as well. But how do you make the decision on who's going to work with who, and do they have backups in case you need to change that in live time?
Sure. Well, first of all 4 of our USOS crew members are qualified to do EVAs, which is a great situation to be in. And so they're all prepared to do any one of these 5 EVAs. We get lots of inputs from different places on the different pairings and the best plan. And of course, lots of things that impact the plan are continuously changing. So for example, when HTV arrives, when the new crew arrives, when the previous crew departs, all of those things impact our pairing. So if you went back several months and tried to look at what our plan looked at that time, it would not be at all what the plan is right now. And so we have to look at the arrival time of the crew members. We want to give folks that have just arrived time to get their space legs, if you will. We want to give folks that are about to depart time to prepare to depart. And so we sort of protect those people around those time periods. So when we were putting this plan together, it made sense to have Christina and Drew perform the first EVA, again, because Christina has done similar work and been actually to this specific work site. It made sense in particular for her. And so in order to maximize the efficiency kind of at the beginning of this series, we wanted to keep the pairings the same for the first 2 EVAs at least. That was an agreement that we had with the program because, as you heard Kirk mention, all of these things can change. We want to be in the best possible configuration that we can be. So the idea is that if you have 2 crew members that are doing similar tasks for 2 spacewalks in a row, you gain some efficiency there. The reality is it's going to probably take at least 5 EVAs to do all of the work that needs to get done. And so one of the priorities that we have is to grow the experience in our cadre and to allow all of the people to gain some of this experience. And so then we open up the pairings to move in different people into the different roles.
Okay, we are going to go to the phone now. We'll try and come back and get a few more here if we need to at the end. But let's start on the phone with Marcia Dunn.
Yes. Hello, can you hear me well?
Yes.
Yes, I had a couple of questions. I'm wondering, when exactly was the medium spacesuit readied up in orbit? And I'm assuming now that it's put together, it will be constantly available for use at any time. And specifically for Megan, I was hoping you could comment. You know, it's been a half year since we were enticed with the possibility of an all-woman spacewalk. What do you see as the significance, the historic nature of this for you personally and for the entire astronaut corps? Thanks.
I'll be happy to take part 1. Megan, you can definitely do part 2. Let's see. First of all, we always had mediums on orbit, and you gotta understand. In addition to the crew selection that Megan just talked about, there is an optimization of crew time as well. So every time you change a suit from one size to another, frankly, even in the same size from one crew member to the other, there's still adjustments that have to be made, and that takes time. So if you really want to optimize time, if that was your only concern, you'd have the same people doing all the EVAs, because you could set the suits up and just bam, 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 do all the EVAs. So it's really mashing all those things together. So we have spares. We have, in some cases, we have a spare hard upper torso, but it doesn't have the life support system, and we can go split those things out and move them around as we need to, but it just takes extra time. We have that perishable science. We have our priorities, and so it's this balance of all these constraints in this really overly constrained problem to come out with what we do. So subsequent to last year, we have launched another suit. It was launched in a medium configuration, so we're in a good shape with that. We don't do it for a specific crew member. Actually, what we do is we look over the next 2 years and look at all the crew members who are EVA certified and say, okay, what's the sweet spot? By the way, we also look at the age of the suits. How many spacewalks does a given suit have before it expires? All that factors into that discussion. It turns out that over the next couple of years, we're having a lot of medium suit people fly, and so that's the sweet spot. That's where we are.
Absolutely. And Marcia, it's hard to imagine giving a better answer than the one that Christina and Jessica gave to the question posed as to, what do they think about when they think about doing an all-female EVA, what the historical significance is of that. I think that, as Jessica said, it's not something that they think about on a regular basis. Part of the team, women here are part of the team. Johnson Space Center is, my experience of NASA. I see women at every level in leadership, in technical areas as well as management areas. And so we are part of the team. And it's not something that fortunately, we don't have to stop and think about very often. I do think that you're right. In this case, it is something to sit back or look back and reflect on. And I know that they'll do that after the fact, after the successful completion of their spacewalk together. I'm sure that they'll sit back and reflect on it, as we all will. We will all celebrate that. It is a milestone, and it just is remarks upon the fact that we have so many women actively engaged in the space program now, that has increased so much even in the years that I've been here. It is something that's wonderful to see and wonderful to remark upon. But again, in our daily work, I think are so well integrated as part of the team that it's not something that we struggle with or that we have to think about on a regular basis.
All right, I think we also have Bill Harwood online.
Hi, can you hear me okay?
Yes.
Yeah, this is a question for Kirk. Kirk, my understanding is your last currently booked Soyuz seat is on the MS-62 vehicle next March or April, whenever it goes. Where do you stand on deciding whether or not you need extra Soyuz seats, given that the commercial crew program has, encountered the delays that it has? When do you have to pull the trigger on that, and where do those talks stand, assuming that they are in fact going on? Thanks.
Sure. I wish I had the answer, a really crisp answer to your question. The fact is that at least I look at all these things as probabilities. So today you can look at, in fact, I have it right here in front of me. I could quote you the exact days of these things. But the fact is, some of those things are likely to happen in a whole range of days. So we have our last seat, a Soyuz seat that we have on contract, that we have an agreement with Roscosmos, is in fact 62S. It launches in March of next year and probably will return in the October timeframe, roughly a year from now. That's the last one we have on contract. So we have dates about when Boeing and SpaceX are going to be ready to fly. And of course, like I mentioned before, we're working with those companies and with the commercial crew program to not only understand where they are, but to provide the maximum flexibility for those guys to take as much time as they really need. We need them to fly safely. We need them to fly, but more importantly, we need them to fly safely. And so what we are doing is trying to find out how can we create as much margin, I look at it as margin, for them to fly. I think you heard the administrator here talk, I believe it was last week, and he mentioned the same thing. So today we have no agreement with the Russians, certainly to, I'll say, purchase another Soyuz seat. It's clearly something that we have thought about. It's clearly something the Russians have thought about, but we have no agreement at this point in time. By the way, I'll mention just because I have this forum and I can do it here, we're actually prohibited by law from spending money in Russia after the December of next year. There's a law, we call it INCSNA, but it prohibits it. And this law has been waived relative to our work with Russia, but at this point in time it has not been waived yet, starting in after December of next year. Not only do we need a contract with Roscosmos, but we need, literally, we need an act of Congress. So we're working on those things. Like I said, it's important that we do not put too much pressure on the schedule for Boeing and SpaceX. We let them work quickly, but safely. And so we're working on it. I hope that sometime in the distant future, we'll have a whole series of methods which we will provide margin that I can talk to you about. But I don't have more to say at this point.
Just one quick follow-up. Is there any consideration being given to extending DM2 whenever it flies, you know, to give you what amounts to a long-duration crew on that test flight? And that's my last question. Thanks.
Sure. We have, as you undoubtedly know, we have entered into an agreement with Boeing to extend crewed flight test up to 6 months, and we are considering all options. So it's certainly something we're thinking about. It's something that SpaceX is thinking about. And again, there's no agreement on that. We're looking at it technically. What is the capability of that vehicle? What is the capability? What's the training of those crew members? So we're looking at all those things, again, as a method of providing margin for the actual rotation flights of crew, but no definitive agreement at this point in time.
All right, I think we've got one more on the phone. Just a reminder, if you do have a question online, you can use *1 to let us know you have a question, *2 if it gets answered. And we will be taking them as questions online as well using the hashtag AskNASA, so you can send those in on social media. Stephen Clark.
Hi, can you hear me?
Yes.
Hi, thanks for taking my question. A couple of questions. First, to follow up on Bill's, can Kirk refresh our memory on why NASA and Boeing agreed to extend the crew flight test up to 6 months and not do that with SpaceX's initially? Like, I guess why go with Boeing for an extension like that before SpaceX? And I have one more follow-up, please.
So when we made this agreement with Boeing at that time, the vehicle that SpaceX was going to fly for Demo 2 was not really capable of doing it. As you know, they've had some adjustments in their vehicles based on some test experience, and that changed the game. So that's why it's now much more in the discussion than it was before. So it was technical reasons, frankly. It was not anything other than that. Things have changed now, and we're looking at it again. So, and the other thing, of course, is the schedules have still continued to evolve, and it changes how you look at it too. So this is not I wish it was. We could look at it today, get the smartest people we could find, decide, and it would be over. But what we do is get the smartest people we could find, get them all together, decide, and then we look at it again next week and do it again. So it's really an iterative process, and frankly, we collectively get smarter every week. We have more data every week. You could argue whether we get smarter or not, but at least where I get smarter. But we get more data every week and make the best decision with the data that we have. We always keep in track of how soon we have to make a decision to really occur. And the fact is that many times you are forced to make a decision with imperfect data. You make that decision, and then you make the best of it. And that's really, frankly, I just told you my job description. That's exactly what we do every day.
All right, we do have a few questions coming in using the Ask NASA hashtag, so we're going to cover a few of those then. We will try and get some more questions here in the room. But I'm going to throw these out together because they're somewhat related. We have Brooks House asking on their kiddos' behalf how much a spacesuit weighs, and Lansantha asking how long a spacewalk can be.
Okay, well, the spacesuit weighs roughly about 350 to 500 pounds, depending on whether it has tools attached to it, whether it has the safer backpack attached to it. So it's fairly heavy. We actually have a model of one in the back over here. You can imagine that it's it has to protect against the heat and the cold and the vacuum of space, but it also has to be mobile. So all of that adds to layers of the suit that make it pretty robust and also kind of heavy. Also, it's changeable in size, so it fits all these crew members that we've been talking about, and that adds weight by adding components that you can change. And all of that makes it a pretty good sized suit.
And how long can a spacewalk be?
Okay, well, I don't know if you wanted to answer that one or not. You want
No, go ahead, go for
it. All right, I'll take this one then. It is, we plan for a 6.5-hour EVA. And that's a good day length that you get up in the morning, you start preparing to get into the suit, you start to pre-breathe. Once you have the suit on and you're ready to go out the door, you've been in there for quite a while. So then we plan for 6.5 hours, and that's the consumables that we built the suit for, right? And we have reserves in that allow it to go longer in case of an emergency, and also if we need to extend. Also, it's based on the crew's metabolic rate, how hard they work and how much oxygen they breathe when they're doing their job. So we plan for 6.5. Sometimes they can end early if we get done early. We look forward to that, to bringing them in safely. We have the capability to run a little bit longer, and really that depends on the tasks that we're doing. For these particular EVAs, for the batteries, we can run a little bit longer, but we plan for 6.5.
All right, and Mrs. Garcey's 8th grade science class wants to know what special training is necessary before a spacewalk.
So I guess we can probably all participate in this one, but spacewalk training on the ground involves, first of all, getting familiar with your suit, getting sized for that suit, making sure that you know how to operate it, and we train to operate it in basically a giant swing pole that we call the neutral buoyancy lab. And so you're in this suit, in the suit, in the pressurized suit, and then they put you underwater and then weigh you out so that you neither rise to the surface or sink to the bottom of the pool. And you have replicas of all of the different types of tools that you might use in space and all of the different pieces of equipment that you might be tasked with moving around. And so we practice these events underwater. And our training program now starts with kind of the building blocks. So learning some of the basic skills about how to move around in the suit and remain safe. And then we kind of expand that into doing more and more challenging things throughout the course of the training. And so right now our current astronaut candidates, the 11 of them are just finishing up their spacewalk training. That basic training consists of about 9 runs in the water, as well as, again, learning how to use the suit. And we go through a whole qualification program to make sure they know how to do a little bit of suit sizing, to make sure they fit in the suit properly, as well as understand all of the systems for that suit, how to troubleshoot and how to do some repair. So it's pretty extensive training. It's very physically and mentally demanding. You spend a lot of time at the gym, basically, getting kind of strong enough to operate in the suit, and a lot of hours underwater practicing moving around. So it's very challenging, which is one of the reasons it's so rewarding. I don't know, TJ, if you want to add anything to that.
The only thing, everything that Megan said is exactly what I was going to emphasize as well. When they get on orbit, there's some additional training that we do for refresher. Those of you who understand that we have a little jetpack that's on the back of the space suit in case one were to go through multiple failures and you ended up free drifting away from space station, you have the ability to fly yourself back to space station on board. Both on the ground before launch as well as on board, we practice those controllable maneuvers. And the folks who are supporting the spacewalk that's coming up with the robotic arm will be going through a number of simulations based upon the computer systems on board to practice the robotics operations as well.
All right, one more, and then we'll do a quick sweep through the room again. This one is from Nathan, and he wants to know how risky or dangerous these spacewalks are.
Okay. So how do we compare? I can give you numbers, and that's probably not fair. The truth of the matter, let me put it in the daily operations of what we do on orbit. Of all the things we do on orbit, putting somebody in a contained suit, putting them outside into the harshness of vacuum, to conduct these very long EVAs is one of the hardest things that we do. So we are sensitive to the fact that this is a risky environment. And the trick in our business and the emphasis of our business is to be able to mitigate and manage the risk and still operate successfully. So I mentioned earlier in the opening statement, we've been working on this for many, many months. I think it's fair to say that the EVA team got started a couple of years ago planning this. It is not done haphazardly. It's not done off the cuff. It is done with extreme prejudice of making sure that we're trying to make everything we do as safe as we can, because we recognize this as being difficult. It is successful in terms of how we do things. We're not going to go into this making a mistake. It's a well-coordinated environment because we understand that it is a little bit elevated in this risk.
Thank you. Okay, I think we have one follow-up from Mark. We're just about out of time, but just enough for that, I think.
Can you estimate how long this series of 10 spacewalks will go? Will this run into December? And then I wanted to go back to the AMS on the number of pumps. Is it 4 or more or something like that? But do you have some sort of, are you trying to finish this up by the end of December, by the end of November, or is that open question?
Yeah, we have an aggressive plan of which we're starting. In fact, you know, you should see, it's not a surprise that we have an aggressive plan. That's why we're starting on a Sunday. That's not typically our EVA day. In fact, if you looked over the last few years, I think Thursday turns out to be our best EVA day. But so yes, we're trying to do these EVAs as quickly as we can, and not quicker than we have been doing spacewalks on the space station. I believe right now, if you include the Russian EVA, I believe is October 30th, and then you start looking at when we would do AMS EVAs. I think it takes us into the beginning of December. So I don't know that I could promise you the exact date on all those, but that's about where we plan today. But that's very, very aggressive. I told you earlier the priorities. And in some cases, we're going to have to pause because we need to do perishable science. Some cases, we're going to have to pause because things were a little different than we expected. So we're prepared to do that. But I think you can expect it. And as for your answer about pumps on in the new replacement of the AMS, I have an idea what the answer is, but rather than me guess, let me look that answer up. I can get it to you really quick.
Okay, I think that is actually all we have time for today. So we are going to wrap up now, but just a few notes before we do. Of course, you're going to want to tune back in on Sunday for the first spacewalk in the series. That's coverage is going to kick off at 5:30 a.m. Central Time. It'll be Christina Cook and Andrew Morgan going out on both of their second spacewalks. And that will be the 219th spacewalk for Space Station Assembly and Maintenance. And again, you can tune in starting at 5:30. I think we will look to get that spacewalk actually out the door a little before 7 Central Time. And then just to go through the lineup again for the spacewalks following that, we will have Andrew Morgan and Christina Cook going out again on October 11th. Then Morgan will be joined by Jessica Meir on October 16th. Christina Cook and Jessica Meir will go out together on October 21st, and then Meir and Luca Parmitano are going to go out on October 25th. Then we'll have more details on the alpha magnetic spectrometer spacewalks as we get a little closer to those. You can look for another briefing. You can keep up with all this news on nasa.gov and our social media channels, but we look forward to seeing you back on Sunday. Thanks.